Hello guys, you are welcome to Socials Pro. In our previous class, we loaded the structure and also did load combination and analysis, where we used this powerful template which helped us to calculate all the primary loads that we needed to apply to a concrete building. We use this template, and the load combination is also from the same template. I've also dropped the link to this template in the description of the video if you need these templates for your designs. In fact, if you are designing any concrete building, you will need this template for your primary loads calculations. And if you are doing your load combination as to Euro code, you also need this template as well. It makes the work very easy for you. Just key in the necessities you need to key in and design is done. So the template is at a giveaway price for now. I would definitely increase the price as we go, but the earlier you grab it, the better for you. So we are going to continue with the structure. Okay, let me just show you the loads which we applied. Self weight, finishes. Yeah, we have a parapet load on the roof beam. You also have uh, the parapet load on beams, under beams. You have parapet load on columns. We have life load on the slabs. Then we have wind loads in different directions. Yeah, this we use that template to calculate. Yes, then we have our load combinations is as to Euro code. So I'll urge you to get the template now that it is very affordable. Before in fact I reduced the price to 50%. I'm running a promo on it. So because some of you requested for this template, and when I made it available, they appreciated it. In fact, most of them are happy. So I urge you to hit the link in the description for your own copy. Okay, what we do is normally we rerun the analysis. Yes, let's just wait for a while. The analysis is done. Of course, we have 0 error and 0 warning. So we go straight to RCDC to design our slabs and beams with columns. You simply click on RCDC here. RCDC is a powerful software. It helps to design concrete members with ease. So here you write down the name of the project. Everything you're writing here will actually come out on the template of the report which RCDC will produce. So it's necessary you write the real thing. Yes, unless if you are just practicing. So you just write the correct name of the project, the correct name of the client, your name as the engineer. So for me, I will just write project 2 story, no 3 story. Write Mr. ABC engineer XYZ, and design code we use EN 2004. Then from here, the right side hand side, you need to choose the member you are designing. So let us start with slab design. So it's asking us the levels, the 0 level in case you want to design the German floor. Yeah, that's zero level. The 3 meter level is the first floor, the second floor is 6 meter level, and the roof level is 9 meter. So everything is there. Just choose the one you want to design. So of course, the first floor slab and the sixth floor slab from our model, they are the same. So I can choose any of them and design for it. So anyone I choose will represent the other. So they are very identical. So I will just click on this first floor and click on create project. That's very good. So if you look at the preview here, you see all the panels. It has been paneled automatically. From here, you can generate your slab layout drawings. Just take it to AutoCAD, export to AutoCAD. In fact, in our next class, what we'll be doing is exporting of drawings to AutoCAD. Yeah, that's what we do. So like this is slab layout. All the slabs have been and beams are numbered. You see beam 1, beam 2, beam 3, beam 39 and rest of them. So you see slab 1, slab 2. So I can still change it to panel. Yes, if I want to call it panels, I can change it to panels. To do that, we go to modify, edit slab description. So here we write panel, click on set. So then I click OK. That's good. So you can see it's panel, right? That's good. So, and you know the meaning of this double arrow in two directions means two ways spanning slab. That means the aspect ratio is less than 2. So that's that. These are the little things you need to know about slab design. So from this left side, you see the full description of all the panels. So two adjacent edges discontinuous. This one is one short edge discontinuous. Here is discontinuous. This one is two adjacent discontinuous, one discontinuous. The same thing. The third one discontinuous, like that. If you come to 9, you see 9 is interior panel. Yes, like that. So for me to do the design is very simple. You can just drag this thing, drag it. Okay, so here I have my staircase here. At this area is where I have my staircase. So I'm not supposed to have slab there. So it's supposed to be open. So how do we do that? We just highlight on this, then you come to this place, it's cut out, false, you say true, is true. Come to this one, see it's already, it has given us that staircase symbol, true, no sorry, yeah, no, false. Then you select this one again, change all these ones to true, and it will open up. That's good. So that means our staircase is there. It's wonderful. So next, I think I will also do a staircase design. So you see how you can use tableau for staircase designs. That's what another class I will prepare. Okay, so we now look at our loads, the imposed load and live load. So this imposed load has to do with the weight of slab itself. So how do you go about that? Um, Simply the slab thickness, I'm going to try 150 at 0.15. The unit weight of reinforced concrete is 25. Good. It's giving me 3.75 kilonewton per meter square. That's an area load. Then I'll add the finishes, which is 1, as stated in that template. Everything is giving me 4.75. So this 4.75 is what I'll put here. 4.75 kilonewton per meter square. The live load, as stated in our template, this wonderful template that has every information that I need to do my design, imposed load, that's live load, is 1.5. Yes, 1.5 according to code. Then the thickness we are trying is 150. I have to take note of the units here. If you put 0.15 here, of course the software is going to see it in millimeters. So you have to be careful. So now this is what it is. Then I will copy and do that for others except the one that is true. This one is not there among. Yes, so the next thing we do is click on settings and I'll check our design parameters. For deflection check, continuous 26, cantilever 8, 030. I'll leave these ones. Then concrete grade, I'll change this to 2530. C grade 410. C grade for Euro code is actually 500. But during production, you cannot be very sure that the strength will come out to be like 500. So for you to be safe with your design, you have to choose a lower value. So that's why 410 is conventional. People normally use 410. So even if after fabrication or production of steel members and the strength is not up to 500, I don't think it can be as bad as 410. So that's why people use 410 for their steel design. So if you go to Eurocode actually specifies 500 for steel grade. Yeah, for Eurocode. Yeah, but um, um, fabrication production of steel members can, due to human factor and some other things, can reduce the strength. So and if you use 500 to do your design will be giving you something very strong and sweet. But in case the strength is not to 500, so you see, you might be designing something that will collapse the next day. So it's better to be at the safer side. The cover here, I will use 50. Okay. Then minimum spacing 150, and I'll use 225 here. That's good. Okay, preferred rebar, use 12 mm. I'll say okay. Go back again, crack width. To check crack, yes, I would like to check crack. Then this one will give me, I'll use 3 and perform. That's good. Then go back again. That's all. Okay, so when I'm done with that, I'll click on auto design. That allows the software to design my slab. So at this point, if you are yet to subscribe to my channel, I will beg you to do that immediately. Subscribe to my channel and share my content with your friends and your colleagues in the office. Let's learn together. Thank you as you do that. So we have everything passed. This green color here shows that all the panel passed. It shows that the 150 slab thickness is sufficient. It's okay. All of them 150 using concrete strength of 2030 and steel grade of this. So the bottom reinforcement is going to be T12 at 225. Bottom reinforcement, and areas where we have top reinforcement, we still have 12 mm at 225. That's that. So that is the slab design. Yeah, slab design. So there are other things we can do. We can, when you come to our report, you can generate general arrangement plan. Yes, you can generate in plan detailing. So in our next class, I will actually do that. Yes, you can also do a slab section. I've done this one before in my previous classes, so you can check my channel. I've done slab section. Yes, staircase section. We'll do that one later. Then design summary. Once you click on design summary, it brings out the reports. Okay, let me just hit on that now. Slab design. That's the summary of design. It shows you panel by panel. LY is 3 meters, LX is 3 meters. Life load as I imputed. Panel type 4. Thickness is 150. Span 2-way. Design code. This concrete grade. That grade of steel. Exactly what I put in. So you now see just the summary as the name implies. The bottom reinforcement is this, top reinforcement, bottom okay is this, top reinforcement, that, distribution, that, everything is there. So with this thing now, if you give a CAD person this, the CAD person knows what to do, how to detail it. We also do manual detailing for those that we if you don't do manual detailing, you will not really understand slab detailing. So we also do manual detailing. I will create a video for that where we will start manual detailing of a slab from beginning to end with AutoCAD. Yeah, this is just the summary of the report. There's also a design calculations. This one is a comprehensive one. It gives you everything, comprehensive report. So that's that. This is comprehensive reports. Very, 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 very long. Yeah. There are other things we can do. Now, next class, I will take time to bring out all the necessary outputs for both slab, beams, and column. That's that. Okay, we will end here today. In our next class, we'll do beam designs and also maybe column designs. We'll be taking it gradually so that I wouldn't rush you to do this one. So we continue next time. I also beg you, if you have not subscribed to my channel, please subscribe. Do that immediately. Do that right. It will just take 2 seconds to hit that subscription button. Subscription is free of charge. Subscription is free of charge. Subscribe, share my content with your friends and your colleague, and even your cousins that are also aspiring to become a civil engineer, a good one, or anybody that has designing tendency. Just recommend my content to them. Yes, and also give me a thumbs up if you have actually learned something from this video. And remember, this template is a giveaway prize for now. So just the link to it is below in my description. So just hit the link there, and it will take you to the payment portal. So you do that ASAP, and immediately you have access to the template, editable template like this. It is very editable. Everything is programmed already. Just put in the values you need to put in, the values you need to know, like the size of your columns, size of your beams. I'm not the one to give you that one. All of them are here. Samples are there. Just edit it like this is the size of this beam, 450 depth, 225 width. So if you have a different one, for example, if I have 300 here, once you put 300, see the weight is already calculated immediately. So if you have a different thickness, say 150, it's also already, and it's calculated already. So this is programmed. So you just it saves you the stress of a long calculation. So that's the importance of having templates. And the strength of every civil engineer or every engineer is what you have in your folders. What are the things you have done in the past? What are the how many templates you have? And it also affects your speed of work. So how many hours you spend in producing a particular job. So if you don't have templates like this, you're actually going to spend a lot of time. You spend enormous time in doing one thing. And if you have this, people will be surprised how you're able to come up with finished work, within a short time, and the work maybe is massive, and they're able to turn it out within a short time. So I urge you to, get this template, and and thank me later. I use template. Any engineer who doesn't use templates like this, yeah, I don't know. Is either you take your time to create yours, or you get something like this and be using them. So I'll urge you to do that immediately. The load combination is here as well. This load combination is I took my time to do them. It's not, if you look at it, you see it's very comprehensive. Like I told you in my previous class, is client approved. This is something I've used to do so many work, and the clients approved those work. They gave comments which I implemented in this template. So it's not like something I did and no one checked it. So it has actually been used in projects where clients check, make comments, refer you to code, and we implemented, and we are out with this thing. So this is authentic, and I will tell you, I'm telling you with my full chest that this is good for you. So just pick it up now that I'm just giving it out, at a giveaway price for my good subscribers, because someone actually requested for it, and that made me to put it there. I wasn't even thinking of this before, but yeah, I can see it helps my students to be more effective and efficient. Okay, thank you. See you next time, and don't forget to subscribe. Thank you.